Hello, everyone. Hi. Okay. I'm going to talk about Bitcoin programmability. And I'll try to go, I know it's translated, so it's hard, but I'll try to go a little slower. I'll talk about programmability, some details, a sort of analogy of a blockchain being a court, the court versus casino. And then I'll talk about two sort of smart contract ideas on Bitcoin, taproot and discrete log contracts. And these are sort of new, but I want to give the general idea. So one thing is, I have 19 minutes and 9 seconds. I can't explain everything in Bitcoin. It's a great system. We try to make it simple as possible, but there's a lot of stuff going on here. So I think it's really important to learn about these things. It's complex. There's no easy answers. There's trade-offs. And I think people realize trying to use Bitcoin in a wide way in this country, it's not yet at the point where it's like a car, where you can say, oh, I have a key, I start the car, I drive. I don't know what an engine is, or a piston, or the carburetor. I don't care. I just drive. That's not really how Bitcoin works yet. Maybe someday, maybe in a few years, we'll get it even easier to use. But I think it's still a good idea to learn about these things if you're using Bitcoin. To know, because it's like if your car breaks down, it was this filter. So if your Bitcoin transaction doesn't work, okay, it was the fee rate, I need to do this. Know a bit more about it. I don't have time for details today, but I'll give some general ideas. But I will say, very quickly, the details are really cool. So that's why I like this, that's why I work on it. Maybe I can entice some people. The taproot equation, P equals Q plus hash M comma Q times G, it's amazing. I remember Greg Maxwell wrote this in an email post, 2018, I forget the date. But I remember where I was. I was in the office of Digital Garage in Tokyo, saw it on my laptop and said, oh, this is what we're going to do, right? It took maybe 3 or 4 years to get into Bitcoin. But as soon as you see it, it's like, oh, this is an amazing equation. It's so simple, this is great. So even though I don't have time for the math is really cool. And it's also really scary, so this is another scary part, right? If you use the same K value, you can lose all your money. This is sort of the equations of losing all your money in Bitcoin. And this has happened in Bitcoin when wallets have reused not just an address, but this nonce K. If you use the same K, your money's gone forever. So maybe this entices. This is maybe sort of like the last one was about being sexy. If you find these things sexy, well, you can look them up and see them online. Okay, but instead, what I'll talk about in the next 17 minutes, the big picture. All these talks, all the technology in Bitcoin computers, it's all really analogies, right? So, for example, this. I don't know if you guys, some people have used these. I used this when I was a little kid. But I know many people I work with, lots of students at MIT, they've never seen one of these in real life. But it means save, right? You save your work, you save your document, you save your email. It's a save icon. And it was based on the 3.5-inch floppy disk, but who cares now? Now it's an analogy. And similarly, in Bitcoin, in computers, and all this, there's no chain, there's no blocks, there's no coins, the way we have coins, even keys and signatures, there's no key. And what you do with Bitcoin, when you have keys, you sign messages with keys, but that doesn't even make sense. You don't sign with a key, right, in real life. But anyway, those are the analogies we use. Maybe we should call them pens instead of keys, and I don't know. But anyway, the analogies help. Otherwise, we're just going to be doing this all the time, right? And it's like, oh, the K value and the R, HM1RX, you can't have conversations that way. Humans can't think that way, right? We need to have analogies. These are the words we use. These are analogies that help us understand. So I want to give another little analogy here. That is the blockchain in Bitcoin. It's like a court. So I think people are familiar with court. I've never actually been to court. I did jury duty once, but you probably don't want to go to court. Usually court is when there's some kind of conflict. Someone is suing someone, or you get arrested, or I don't know. You generally don't want to go to court, but it exists, and it's an important part of society, civilization. And you can think of the blockchain the same way. It's expensive. People don't want to go to court because lawyers are very expensive. The court system is very expensive. And the blockchain, right now, it's not too bad in terms of fees, but it can be very expensive. You have one sort of court for the whole world that is Bitcoin. And it's public, right? You see what happens. You can enforce contracts. You can enforce Bitcoin smart contracts. But the idea, the sort of philosophy in Bitcoin is we don't want to always use the court. right? Just like in real life, if you have lawyers signing large contracts, they designed it in a way that they don't have to go to court. You sort of get everyone to agree on the terms. Similarly, I've signed many contracts. I have employment contracts, rental agreement when I rent an apartment, or things like that where, yeah, we have all these contracts, we sign. We could go to court if something goes wrong, but because you see that everything's spelled out, you don't have to, right? So this is a very good analogy for Bitcoin smart contracts, I think. Yeah, don't compute, verify. So the idea is even more than a court. It's sort of like a super court because it's deterministic. It's just a computer. Unlike in a real court, there's a judge, maybe there's juries. You're not exactly sure, right? But lawyers will tell you, oh, you have a really good case. Or, this is a long shot. Are you sure you want to do this? You should settle. In Bitcoin, you know exactly what will happen. Why go to court if you know beforehand what the judge will say? So if you know you will lose the court case, just settle, give the money to the other person. So similarly in Bitcoin, you want to make it so that it's predetermined and there's no reason to go to court. So you also want to give the court the minimum information to decide. Don't compute a smart contract. Don't have the Bitcoin blockchain or network figure out what is happening. Just prove, hey, here's what's happening, and then it happens. Yeah, so there's no reason to go to court, which is good. And this is sort of an analogy like court versus casino. There are many platforms today that are much more focused on smart contracts, right? I would say even though Bitcoin does support smart contracts, for most people, they're using, sending money, saving money, investments, and that's cool. But there's other platforms that are just, all we do is smart contracts, everything's smart contracts. And despite this, they run in a way that doesn't feel like a court. It feels more like a casino, where you're doing lots of fun things. Casinos can be very fun and interesting, and hey, you win lots of money or you lose lots of money. But you don't know what's going to happen until you roll the dice or until you flip the cards or whatever. So in many of these systems, it's much less deterministic, and the blockchain is deciding what happens, not just enforcing what already has been agreed on. So this is to me sort of an analogy of the Bitcoin one. Maybe it's not as exciting, right? Casinos are kind of boring. Casinos are exciting and there's flashing lights and court is just bland building. But I think courts are more important than casinos. More fun, but you don't know what will happen in the casino. So I want to talk about two programmability kind of things that we use in Bitcoin today. And these are not as widely understood. Maybe Taproot is quite new, so people don't know as much about it. And discrete log contracts is not as new, but still getting built out, and people are still starting to use it. So I'll describe these. And I hope it gives a sort of general idea of the thinking behind the people making smart contracts and programmability in Bitcoin. And I don't want to say at all that these are exclusive. There are many other ideas. What are some? OpCTV, the op check template verify is a really important thing people are trying to do for more programmability in Bitcoin. SigHash, any pre-vow. There's lots of other work. I just picked two because I thought they had some similarities and maybe it would help give the idea a bit. Taproot is one that activated recently. Oh, it's gone. Oh, yeah, okay. Taproot is one that activated recently, last week, I think, and was under development for quite some time. And it's very much built on this don't compute, just verify idea. And it's especially built on the fact that, most times everyone agrees. So if you make a contract, most of the time everyone agrees, yep, you need to pay this rent for this apartment. Okay, the apartment is good, the rent is good, everything's fine. You don't really need to go to court. So this sort of diagram. What Taproot does is it makes it so you have your address, your public key, but it hides things in that public key. So the idea is that the public key is sort of the everyone gets together and signs together path of this contract. And if you don't agree, if something went wrong, or most likely someone has disappeared, right? You make some kind of contract like Lightning Network or discrete log contracts, and someone has disappeared. They just went offline, or they lost their computer or phone. Then you can reveal, you can say, hey, not only is there this key, but there's also this script sort of hidden in the key cryptographically. You don't have to show this. If you want, you can say, here's the key with everyone signing. Everyone signs an aggregate signature. It's very small. It's very private. You don't even see, in this case, that the script existed. but you have this backup plan, sort of going to court. Say, okay, well, my counterparty is gone, so I will reveal script B, and then I will also reveal that there's components of this script. So, hey, there's actually a script here, now I'm going to use it. And this is a little more costly because it's bigger, right? There's just more bytes, right? The top way, what is it going to be like? 64 bytes, right, for a signature. And then the bottom one, you get into the hundreds, a few hundred bytes. So it's a bit more, but the idea is, well, hopefully this is like 90%, 99% of the time. And the lower ones are infrequent. And when you need to, right? It's okay. And then you could sign different things, like maybe it's Alice can sign tomorrow, or Bob can sign if he has some proof or something, and put the scripts of the smart contract sort of hidden away, and you only show what you need to, right? So if Bob is the one signing, he will show script and then his key. He won't even show that Alice's key exists, right? It's not important for everyone to know that Alice could have signed. It's just important to know, okay, Bob is allowed to sign, and he did, and so it was a valid transaction. So you keep, this is a bit different from court, so this is where the analogy maybe breaks down, but it's a contract where you only show the very small portion that you're using, right? The rest of the whole contract never gets to court. You're just saying, okay, this happened, he's doing it, you're good. So that's sort of the idea of how Taproot works. Then I'll talk quickly. Discrete log contracts. This is a paper I wrote a few years ago, and it's great to see this week there's companies using this technology and building startups, building smart contract platforms to do this. It deals with real-world bets, and one of the problems that has been sort of people thinking about with real-world transactions, for example, I want to bet on the price of oil, or I want to bet on the price of gold, or Bitcoin. Maybe I shouldn't say bets, but to me, everything's a bet. Like even insurance is bet, where I have car insurance, and basically I am saying to the car insurance company, I bet I'm going to crash my car. And they say to me, I bet you won't. And then we make a bet. And if I win by crashing my car, they give me money. And if they win, because I don't crash my car, I have to give them money. But maybe that's a silly way to look at it. But if you look at finance, it's all bets. It's a one way to model this. And from working on this, it sort of feels that way. But what you need is you need an oracle, right? So did the car crash? That's not something that's on the blockchain. What is the price of oil? That's not in the Bitcoin blockchain, right? You need some real-world data source. And that is a big problem because maybe this data source, this oracle we call it, could be bribed, right? Maybe someone could say, hey, say that the price went down even though it went up because my smart contract will make me money. Or the oracle can lie in different ways. So we want, the idea behind discrete log contracts is the oracle who supplies the real-world data doesn't see the contract, right? They are just sort of a radio station or like a newspaper saying, hey, the price of this stock today is 23. And then the users, the people making a contract, can take this data from the oracle publicly and put it into their contract, and no one can see that they did this. So it's very private. They know we are betting on the price of oil, but the oracle doesn't know, and everyone else on the blockchain doesn't see. So I think it's pretty good for privacy that way. And here's a little diagram of how this sort of works. I don't know, maybe it's too complicated, but it's similar to Lightning in that two people say, okay, let's make a bet. Well, in Lightning, they say, let's make a channel, and we can move money back and forth to each other. In discrete log contracts, two people say, let's make a bet. I bet, Alice says, I bet it will rain tomorrow. And Bob says, no, I think it'll be sunny. And so what they do is they build these outcomes. So every possible outcome is its own Bitcoin transaction. Right? So they say, okay, well, if it's cloudy but doesn't rain, we just get our money back, right? Alice puts in 5, Bob puts in 5. They have this 10 Bitcoin address, UTXO, and then they say, well, if it's cloudy but doesn't rain, then we just get our money back. But if it's sunny, Bob wins most of the money. If it's rainy, Alice wins most of the money. And then there's this oracle up here that tomorrow it's the weather station, maybe weather TV or something, and all the oracle has to do is sign and say, okay, the weather today was cloudy. And then once the oracle signs cloudy, this transaction in the middle becomes activated in a kind of fun cryptographic way. But it's activated in a way that no one can link this happening. Just from looking at this transaction, you don't know that the oracle even signed cloudy. You don't know that these are connected. Alice and Bob know because they take the oracle's signature to make this happen, but other people won't know. And so this is a nice model because from the Bitcoin network's perspective, all you see, Alice and Bob put 10 Bitcoins together, and then the Bitcoins fly away into 5 and 5. Why did this happen? It just looks like a normal transaction. You don't see that there was any smart contract involved. So that's, to me, that's the perfect, privacy and anonymity for this. So the issue, I guess, is sometimes it gets a little big, where if you have like maybe hundreds or thousands of possible outcomes, right? If you're betting on not just a weather, but like a price. Hey, what is the price of gold tomorrow? Well, there could be a lot of different prices. You have to sort of round it. So maybe let's round to the nearest dollar. So maybe there's a few thousand outcomes, and you need thousands of these instead of 3. It's still doable. It takes a few seconds. Computers are quite powerful, so you can have thousands of this, and it only takes, a megabyte on your computer. And I think that's actually a good way to think about this in general. In Bitcoin, it's better to make it slow for the people doing the computation, right? Same as Lightning Network. It may take a lot of data on your laptop or your phone. You don't want to put all that data on the blockchain, right? Because if you think about it, there's probably 10,000, 100,000, there's many, many people running the blockchain, right? Running the node. And so you want a large ratio of, I would rather have 1 million times more data on my computer than put that for everyone's computer, because there's maybe 1 million people using this, right? So maybe I will store 1 gigabyte of data just to save 1 kilobyte of data on chain. And that's an okay trade-off, right? I have 1 gigabyte, it takes a little while, but I can save that. So this is why I think this is a good model for this. Okay, I'm gonna finish up. Yeah, so if the Oracle signs, only this happens, you never see the rest. Okay, so what are some use cases for this people are looking at? Currency. I think the best would be short and long Bitcoin price. We see people using things like Tether or stable coins that are kind of maybe dangerous, maybe sketchy, but with this you could say, oh, I think Bitcoin's gonna go down, or I just want a stable dollar value for now. Or people say, oh, I really think Bitcoin's gonna go up. I want to leverage my Bitcoin. And that's a trade, right? That's two people that disagree. They think, hey, I bet you Bitcoin goes up. And then the other person says, oh, I bet you Bitcoin will go down. And whoever wins gets more Bitcoin. And they're happy, right? They want to make that bet. You could do commodity sports. I think it works best when the Oracle is widely used. The anonymity and privacy probability of it doesn't help if it's a private thing. If you say, oh, did you eat your vegetables? Let's make a smart contract. Well, who's the Oracle going to be, right? If the mom says to the kid, let's make a smart contract, the mom's going to be the Oracle, or maybe the dad. So it's not really independent. You want something that's widely agreed upon so everyone can see this. Yeah, so that's that. Okay, so just to wrap up with Bitcoin programmability, I would definitely say Bitcoin is advancing. There's so many people building really cool tools and networks on top of this. It doesn't maybe get as much attention as the sort of casino stuff, where people are building all these kind of flash loans and crazy bugs, and that's probably more fun, and I read about that too all the time. I'm like, whoa. But this is sort of, the emphasis is more on privacy, efficiency, and security. It's not a sort of move fast and break things, but I think there is a really good future for programmability in Bitcoin. So, thank you. Gracias.
Thank you so much.
Thanks.
Hey.
Thanks.
Wow. Thanks for I don't need it, no.
Okay.
But isn't it amazing to have the inventor of Lightning Network here in Lightning Network country, and even the luxury didn't even talk about Lightning. This is only possible at LaBitConf, right? Thank you so much, Staj.